Okay, awesome. So good afternoon, everyone. Thank you all for coming to workshop today. We will be looking at starting off with basically reactions of phenols, how to make them, and then further on in subsequent workshops, we'll look at how they react. But we'll start off with just reactions of phenols and how we want to make them. So there are a few ways that we can make our phenol species. And when we talk about a phenol, right, so synthesis of phenols, what we're saying is that we want some aromatic ring, and on our aromatic ring, generally it'll be our 6-membered ring. We want to add an OH, our hydroxy group, right? So that's what we'll call our phenol functional group, or our phenol organic molecule. And there are a few ways that we can make it, right? So we can start off by using our sulfonated species, right? And in the presence of base and heat, NaOH, and heat, we can generate a phenol. Another way that we can get to this phenol product is if we start off with a haloarine, right? So if we halogenate our arine, we can also once again use a base, NaOH, in the presence of heat, and this will allow us to generate our phenol. And then the last way that we can generate a phenol, or the last way that we have as a resource to get there, is to use our diazonium species. So N2 plus, then our double bonds are here, right? And in this case now we'll need water, we'll need a strong acid like H2SO4, and then we'll also need heat, so around 100 degrees Celsius. So those are three ways that we can generate our phenols. So now let's start with looking at the reaction of our sulfonic acid with a base, sodium hydroxide, to generate our phenol. So in this case, what we're thinking about for our reaction, so we're looking at our first reaction here to get to our phenol. And for this first reaction step, really what we're thinking about is an addition elimination mechanism, right? So we have our aromatic species. We have our aromatic species, and we have SO3H present on our molecule. And then you can imagine that in the presence of a base, which we'll write our base as OH minus, right? We can get attack of our base, a base attacking our carbon, right? We'll push electron density to our molecule, right? And now, in the next step of our reaction, so now we have a double bond here, we have SO3H, we have also an OH here, and then a negative charge present here. You can imagine that for our acid, we can deprotonate our species, right? We can deprotonate our species, and when we deprotonate, we actually have made a better, sorry, we don't want to deprotonate. So we have, let me just take that back. Yeah, so now we can think of having a negative charge on our carbon, right? And then when we regenerate our carbonyl, we'll lose our good leaving group. And this would be our elimination step. So now we have we've regenerated our triple bond, and we've replaced our SO3H with just OH, right? So this is our addition elimination mechanism. And what we're saying is that we have addition first, and then the best leaving group is lost, and then our sulfur containing functional group is our best leaving group. So we'll see that, and then we can restore aromaticity here. Okay, so that's one way that we can generate our phenol. Another way that we can generate our phenol is the reaction of a haloarine, right? So we can take Cl on our aromatic species, reacted in the presence of NaOH in heat, and this allows us to generate something that's really unique. We'll generate our we'll generate our Benzene intermediate. Right, so this is our Benzyne. This is our Benzene intermediate, and then in the presence of water, this acts as a nucleophile to generate our phenol through an addition. Right? So we'll look at that mechanism in a bit more detail. So this is another elimination addition mechanism, but now, after we generated our Benzene intermediate, our water acts as our nucleophile to generate our phenol, and then with protonation, we'll reprotonate. With deprotonation of our water, we'll reprotonate our carbon there. Cool. And then lastly, in order to, another way that we can generate our our phenol is through the hydrolysis of our diazonium salt. So in this case, we'll take, so this is the last part over here, right? So now we want to take our diazonium species. So now we just have our ring. We have a nitrogen with two nitrogens with a positive charge in the presence of H2SO4 and water. You can imagine that we're going to have a similar reaction where with our diazonium salt, we can convert it to a phenol, right? So we'll get rid of N2 as a gas, and then we'll use water as our nucleophile to add our OH or OH2, right? Our protonated water, and then our acid can allow us to, or the conjugate base of our acid will allow us to deprotonate.